Yesterday we have discussed distributed generation. Before that we have discussed some significance of microgrid. The operation of microgrid we have discussed in hybrid mode, in islanded mode. We have seen the types of microgrid also, AC, DC, hybrid, based on the supply, renewable, solar, wind, biomass, small hydro, diesel, hybrid, that is depend on the source, residential, industrial, commercial, based on the scenario, less than 10 kilowatt, 10 to 1 megawatt, greater than 1 megawatt, based on the size. In AC grid, DC grid we have discussed how these microgrids are connected to main grid, AC microgrid, DC microgrid, and then their interconnection with main grid, loads. Okay, these all things we have discussed yesterday. Okay, I think no doubt. आणि असं काही नाही, इफ यू हॅव डाऊट यू कॅन आस्क. मी तुम्हाला प्रत्येक वेळेला ही संधी देतच आहे. ओके, in between, hello,
centralized generation आणि distributed generation.
Okay, that difference you need. Okay, आणि काकडे वैष्णवी काकडे, युअर मायक्रोफोन इज ऑन. तुला काही विचारायचं असेल तर विचारायचं, अदरवाइज पुट ऑफ युअर मायक्रोफोन.
नाही सर, बंदच आहे.
नाही ना, मायक्रोफोन चालू आहे. ओके, ठीक आहे. ओके, so distributed generation we have, in which we have centralized and distributed generation. Okay, so distributed generation we have started. So distributed generation we have, especially the distributed generation is in the form of small scale generation. Have you understood this? Small scale technology, small scale. आता आपण we have seen not more than 1 megawatt we can go for distributed generation. In centralized generation, what we have mega power plants. So we can have the small scale technologies that yield. For a distributed generation, you have combination of various sources, then you may go up to 100 megawatt. But if you see the centralized generation, in centralized generation we have the capacities in terms of hundreds of megawatts, say 100 megawatt, 200 megawatt, 500 megawatt, 1000 megawatt, like this. So centralized generation system that we have already, we have connected them in grid. Centralized, why we say centralized? Because all these big generators are connected together, means especially by using the fossil fuels. You may say the thermal power plants, big hydropower plants, you may say the gas turbine power plants, you may have other nuclear power plants. Those power plants are having big capacities and they are connected together to the conventional grid. And now we have this conventional grid, we are converting it into conventional grid into smart grid. So it may be a national grid, it may be a state grid, it may be a regional grid. So that is a centralized generation. Okay, means all the generators are connected together to form a common source of power. What I am saying, have you understood? So that is a common source of power, and means you are having the common source, all generators are feeding to the grid, and all loads are connected to the grid to absorb the power. So all generators are feeding to the grid and all loads are taking power from the grid. So that is a centralization. What is decentralization? In decentralization or in distributed generation especially, that is not commonly connected together either state wise or nation wise or region wise. म्हणजे distributed generation doesn't having state grid, regional grid or national grid. Okay, but but distributed generation is having local grid. Look in that area, suppose in particular area, say Ahmednagar district, you are having one particular area, say any Tahsil place, if you consider, and you have suppose we have considered one of the Tahsil places, Srigonda, in which you are having abundant land available and you can have solar power plant over there. So that solar power plant is feeding power to the local area. That is a distributed or decentralized generation. If it is possible, you can add some nearby wind to that. So it will be hybrid power plant, decentralized, and it can be work in islanding mode, isolating mode, since it is locally feeding the power. If the decentralized generation or this particular power plant is having capacity to sell the power, means if the power plant is having excess power, then the same distributed generation grid can be connected to a national or central grid. Okay, so that is a basic difference between distributed, means you want decentralized generation and centralized generation. Okay, so this is what we have the diagram. Here you are having all big power plants are forming a national state grid like this, but this is a local grid. It is feeding power to the local load, but if excess power is available, then you can synchronize this distributed generation or decentralized grid to central if it is required. Otherwise, and if this is having some problem, the load may get fed from centralized grid. That is difference. Okay. Any more? Anybody having any more requirement? Very good question. Definitely distributed generation, as far as diploma level is concerned, it is very difficult to understand what I say. Because distributed generation, micro grids, and all these concepts are emerging concepts, and all these emerging concepts are now research is going on. Many people are doing MTech and PhD in this particular, as far as academia is concerned. But in spite of academician, the work is also going in actual field on particularly the micro generation, micro grid, distributed generation, and all this. Maybe in future again we may have major power that will get feed to the load with microgrids and distributed generation. Okay, so in future it may be like this. Okay, because we are reducing major role of this particular distributed generation or microgrid or micro generation with what we can say the renewable energy sources is to eliminate or to reduce the use of fossil fuels. Have you understood this? So in future we know that the fossil fuels are no longer going to be there. Their storage is coming to end. So what we can say, definitely there is a shortage of this, and it is difficult to generate power with conventional power plant. So we have to move. Other options are microgrid. Other options are distributed generation. Okay? Yes. So need on significance of distributed generation, what I told you, all this increased demand we have discussed, high risk of, I think no need of more elaboration in this, because we have yesterday already gone through this deeply. If you have doubt, you can ask, but from my side I think I have discussed much more. पण तुम्हाला गरज असेल तर तुम्ही विचारू शकता. बोला.
सर डिस्ट्रीब्युटेड जनरेशन मध्ये सर आपण वेगवेगळे जनरेटिंग पॉइंट्सला मायक्रोग्रिडने कनेक्ट करतो की कन्व्हेन्शनल ग्रिडने?
Initially it is a microgrid. आपण इथे एक फिगर बघितलेली आहे. Go to this particular. This is a microgrid. See.
तुमची स्क्रीन शेअर.
My screen is not get shared. स्क्रीन शेअरिंग नाही झालेलं अजून. अरे यार तुम्ही सांगायचं ना पटकन. आय डोंट. ओके ओके ओके. स्क्रीन शेअरिंग या प्राचीच्या क्वेश्चन मुळे राहून गेलं. तसंच करायचं. ठीक आहे. नाव इट इज ओके. हा. So here you can see this is PV, this is wind, this is energy, fuel cell. Fuel cell is also source of energy. आता these are micro generation. PV is micro generator, wind turbine micro generation, fuel cell micro generation. All these three different sources are connected together to form a, this is a grid. Okay, एवढी ही ग्रीड आहे. हा, दिस इज अ मायक्रो ग्रीड. AC मायक्रो ग्रीड म्हटलंय खाली इथे, बरोबर. तसंच यू मे हॅव DC मायक्रो ग्रीड. सो दिस इज मायक्रो ग्रीड. इफ रिक्वायर्ड विथ दिस सर्किट ब्रेकर इथे दिलेलं आहे. आणि दिस इज इंडिपेंडेंटली फिडिंग टू द लोड. म्हणजे हे काय झालं, जनरेशन, डिस्ट्रीब्युशन, ट्रान्समिशन हे ग्रीड साठी, बरोबर ना. दिस इज मायक्रो ग्रीड. दिस इज नॉट स्टेट और नॅशनल और रिजनल ग्रीड, but this is a local grid. What we call it as a micro grid. Max capacity is 1 megawatt. As on आपण डिफाइन करताना 1 मेगावॅट जास्तीत जास्त एका मायक्रो ग्रिडची कॅपॅसिटी असेल. आणि जर गरज असेल तर दिस कॅन बी सिंक्रोनाइज्ड विथ द मेन ग्रीड. इथे दिले बघा, विथ दिस कपलर सर्किट ब्रेकर. अदरवाइज इट इज वर्किंग. हा सर्किट ब्रेकर ओपन केला, द मायक्रो ग्रिड वे और दिस डिस्ट्रीब्युटेड जनरेशन विल वर्क इंडिपेंडेंटली इन आयलँडिंग मोड. हे जर कनेक्ट केलं तर इट विल वर्क विथ सेंट्रलाइज्ड ग्रिड इन सिंक्रोनाइजिंग मोड. ओके, सो दॅट इज डिफरन्स. सेम हियर. आता एक लक्षात घ्या, AC आणि AC लोड असं का म्हटलं. AC टू AC कशाला कन्वर्जन करायचं आहे. सम लोड्स आर रिक्वायर्ड लेस फ्रिक्वेन्सी, सम लोड्स आर रिक्वायर्ड मोर फ्रिक्वेन्सी. ॲज पर रिक्वायरमेंट ऑफ दिस यू कॅन कन्वर्ट. और सम लोड्स आर रिक्वायर्ड डिफरंट व्होल्टेज. इथे 400 व्होल्ट असेल, इकडे 230 पाहिजे, तर परत तुम्ही AC टू AC 230 करून यू विल फीड टू द लोड. AC DC काय म्हटलंय तर यू आर हॅव्हिंग इनपुट AC DC requirement of load, you can convert it and feed to the DC load. Here you are having the generation in the form of DC, so this is in the form of AC, this is in the form of DC, this is in the form of DC. Grid is DC, so all it is converted into compatible DC to the microgrid. Then you may have a DC AC load. You may have converter, DC to AC converter, 6 pulse असेल. आता 6 pulse 12 pulse converter we are using as on today. You can convert it into AC required frequency, feed to the load. DC you can convert into the AC of required frequency and you can feed to the load. DC you may convert DC into required DC voltage level and feed to the load. So this is microgrid. You may have DC grid, you may convert DC into AC and then you will synchronize this DC grid with microgrid, main grid. So okay, so like this. आणखी okay, I think it is okay now. Any more? May I move to the next point? I will move to the next point. One minute. So I think this was our last part of discussion, na? Okay, 1 minute. I will